Right, so today we're doing Java 4 lesson 5, and today we're learning about something called comparing methods. So as a review, I don't know if any of you remember it specifically, but back in Java 3, when we talked about tree sets and tree maps, I mentioned comparing methods. So that's what we're kind of learning about today. Comparing methods are just how tree sets and tree maps order their values. Since if you remember, they're the sets and maps that order things by specific orders. So anyways, the following part here is just a little bit of a general note. But since we already learned about interfaces, it's a bit easier for me to tell you now. So list is an interface array list and linked list implement. So list, again, if you think about it, list is the general as general components for array list and linked list. So they implement that list. Set is an interface hash set and tree set implement. Again, set contains some vague component set. Map is an interface hash map and tree map implement. And collection is an interface array list, linked list, hash set, and tree set implement. So you can see how they're all interlinked together. And also these names are kind of self-explanatory, so it's easy to remember them. You can always think array list. What does it implement? A list, right? It literally has it in the name. So again, with hash set and tree map, that kind of thing. Collection, usually I've been referring to all of these hash set, tree set stuff. I always refer to them as collections, so no way you can remember it that way. Just notice that apparently hash map and tree map aren't in here. Anyways, so usually when we went over tree map and tree set, it was able to order basically everything, strings and integers. It was all able to order that. But just keep in mind that not every single tree map and tree set will be able to order regularly without any extra implementation. So specifically, this is geared towards a tree set of objects, because if you create one yourself, it's kind of hard to do it. Since you're creating it yourself and Java doesn't know how to order that. So if you were doing a tree set of some random object that you created, then you would have to add some extra implementation. So the first compare method is an interface named comparable that would help to fix that. And to be able to order, you would have to implement comparable, which is an interface, and then override the method compared to that is in the comparable. So I know that you'd have to import java.util.*, semicolon. And that's just general rule again, if you remember, for everything in collections. So array list, actually not. Yeah, array list, linked list, hash set, tree set, you'll have to implement this import java.util. So kind of one relating comparable. And you can notice that the code is kind of weird, but just assume that this part goes right after this. I didn't have space to really fit it all in one column, so hopefully you understand. Anyways, so this kind of looks like always class random implements, and just notice here that instead of just having the name comparable here, you have to put a generic type in there. So just interface is kind of the comparable is kind of an interface with generic typing. So you have to put something in there, and usually what you would put is the name of the class, since you're basically saying that since comparable takes in a generic type, you're basically saying that, oh, I give you the type of this class so that you can help me with other classes. But yeah, so generally you just put whatever the name of the class is in here. Then you do int a, setting an instance variable. And this is an example of a compare to method. And one of the specific stuff you have to put in the parameters is an object of the random, like an object of random, since you want to compare it to something, right? So you have to pass in something. So this is something that returns an integer, and you can see here that we have some weird stuff if you've never seen this before. But what it's saying is that we're basically testing different stuff to make an order of something. So look, if you look here, if A is less than R.A, so basically saying that if the A of this class is less than the object that we passed in is A, then we return -1. If A is greater than the R.A, then we return 1. And if none of that applies, then we return 0. So I have an explanation on next line, I believe, so I'll explain it in a second. But this is generally how a compared to method looks, and this is generally how like the implementation line looks of the comparable. Right, so explanation. So by overriding the compared to method, you can set your own ordering rules. So yeah, since like usually like if you use compared to with objects without implementing it again or writing it, then you're going to get an error most likely, or it's not going to order correctly. So by doing this, you can set your own ordering rules, and that makes it a lot easier. For example, for determined output, and you can like actually set it for your own. You can also do this with like strings and integers if you wanted to. So it doesn't really matter which you're doing it with, as long as like the compared to method in general just makes it so that you can reorder stuff. Anyway, so therefore you can make it so that your true set or true map orders from greatest to least, and so on. Since usually true sets and true maps order from least to greatest, so you can always change it from greatest to least, and so on. Yeah, again, you can determine for yourself what kind of thing you want to base your ordering on. So what I mean by that is, you can see here that I based the ordering here off of the instance variable A. And like you don't have to base it off of that. You could like do a lot of different other things with it. Like, I don't know. You could do many different things with it. You could do like you could probably do, if you had display method, you can compare display method outputs, like that kind of thing. You could do stuff like that. You don't have to base it off the instance variables. It's just generally, it's easier to do with instance variables since they're like kind of the, again, if you remember me talking about classes back in Java 3, I mentioned that these variables are also something called attributes. And if you think about the word attributes, they mean like they're the character or something, right? They're the defining parts of class, sort of, but you get what I mean. Anyways, so that's why we usually use instance variables, since it's easiest to base it off. But you can do it on anything you want. So for this specific example, it returns -1, meaning less than, if the object that's using the method is less than the object passed in. So in that case, when it's ordering, if it returns -1, that means that the object that's using the method, that the one that you're passing in, that means that object is less than the one that's already there. So, and in that case, you order the object that was passed in after the object that's there already. So same kind of thing here. If it returns 1, great, and that means greater than, if the object that's using the method is greater than the object passed in. And in that case, the object that was passed in would be moved before it. And it returns 0 if the object and the object passed in are equal. And yeah, wait, give me a second. I think in this case, we're doing it. Yeah, I think in this case, it's ordering it in descending order. Yes, I believe so. Maybe. Sorry, my brain is kind of blanking out. Yeah, I think it's ordering in descending order. It's been a while since I wrote this. Anyways, how you know that is because usually, remember, when we're returning, we're basing it off of this passed in object. So when we're saying that, so if A is less than r.a, usually we would say you put -1 actually. Oh, sorry, no. If A is less than r.a, we usually say return 1. But in this case, we're returning -1. So that means that we're ordering in descending order, so opposite order from what usually happens. Same thing here, it's the opposite. So in return 0, you may find that if you don't put this return 0 here, you're going to get an error since there's something called like the locality of something, I think it is. It just matters with like where the return statement is. So even like, because you have to return something, right? You have to int here. If you don't return something, then again, you're going to create an error. But Java doesn't care whether or not there's return statements inside of if statements. It has to be outside, since with if statements and for loops and all that, I think I mentioned this before, but they all are concentrated in a certain area. So when the return statement's inside the if statement, Java's like, when it goes through it, it's going to disregard that. So in that case, when it goes through this, if you don't have this here, it's just going to assume that you didn't put a return statement and it's going to get an error. So usually in general, it's a good idea to just put the return 0 here so that it's a good catcher, since if none of these evaluates anything, then it's most likely that they're going to be equal, So it's just generally a good idea, since 0 signifies that they're equal. Generally a good idea to just put this at the end. All right, I went over that. Continued. So usually it would be a good idea to use the equals method to test the equality of the two objects before returning 0. So be sure to do it usually, since again, this kind of means that you're going to have to implement the equals method yourself. And yeah, it's just generally a good idea to test at the beginning of the comparative method, so that if it is equal to each other, then you don't have to run through all of that, and it just saves a bunch of time. Not a bunch, but like saves some time. You don't have to do it. Usually that return 0 at the end of it would function pretty well, but it's just better work that way if you do it. Yeah, so like I said, you'd have to override the equals method before using it in the comparative method. Comparator. Okay, so there's like 3 or 4 structures that you're gonna learn about with comparing, and second-ish one, third one. So a comparator is something you use on a tree set or a tree map, maybe, to change the ordering of things. So note, this is for numbers and strings and so on. Since usually comparables is used for objects and comparator is like used for everything else. Yeah, you usually wouldn't use a comparator for objects. Anyways, yeah, so note that for strings, you have to use a comparator to be able to order it properly, since it's considered as an object. So that's something to note there. Example of a class that uses comparator. Just note that comparator is an interface as well. It goes on the next page. Code example of comparator. And this is also continuing on 2 pages, so don't be surprised when you only see this here, but like it's coming. So if we create a tree set of integer, and weird thing is you can see that usually when you're creating a tree set, these parentheses at the very end of it is left empty. But in this case, we're adding something inside of it. And so this is how you use a comparator in the tree set. These parentheses are specifically for if there's any extra ordering. So this is where you put the comparators in and that kind of stuff. So usually it'd be empty, but if you had like a comparator that you wanted to specifically order the tree set with, then you add it in there. So the continued part. So this is where we're doing like the comparator. So you can see it looks basically the same as the comparable, except we're implementing comparator. And also this time we're not using the name of the class, we're using integer. So primitive data type for wrapper class. And just notice here that I miswrote on the first slide, but for comparator, instead of doing compare to, you're doing compare this time. So just make sure that you understand the difference between that. And notice again in this case how we're not using the name of the class, we're doing like integers. Again, just notice that it has to be integer. You can't do int or string. It has to be integer since, remember, this is like a generic type up here. So if we look back at the generic coding for comparator, you can see that like compare uses like the generic type for this here and here. So that's why it has to be integer. It can't be int, it has to be integer, since otherwise you can create an error since you don't have matching generic types. Okay, again, you can see here that if I remember correctly. Okay, no, I think this is ordering in actual order. Yeah, so again, you can see here that it's basically the same as before. It's just integers. Again, like returning integers. It works the same way. -1 means it's less than, 1 means it's greater than, 0 means it's equal to each other. And you basically do the same thing as in compared to, except you're doing different values this time. So you have to be sure that you're ordering based on whatever you're doing, since it's important. So if you had a string tree set, then make sure to do something with the tree strings. Yeah, otherwise it's basically the same. Just notice how it's a class, right? Class random is a class. So in here, since we don't have any constructors, so it's fine if we don't add anything in between the parentheses. When you're putting the comparator inside here, make sure you're doing new random since it's a class. So you're basically creating an object of it. So that's why you have to do new random. So that's the first one. Okay. Comparator explanation. Or just making sure I didn't miss anything. Okay. So, okay. Apparently I got it wrong again. You can notice that like it's sometimes really hard to do this since it's really confusing sometimes. But anyways, this comparator example apparently will sort everything in descending order. Be sure to make your comparator consistent so that everything is ordered properly inside of your tree set. So, for example, if you entered compare A, B, then and it returns -1, then if you enter compare B, A, it should return to 1. So if you don't have consistent ordering, then an exception will usually be thrown. So that just means to keep it consistent, since you don't want it so that if you enter one thing and then you enter the other thing is going to return something completely like it's going to enter the same thing, you know, since tree sets and tree maps, like they're based on ordering. So if you don't have good ordering, then what's the point of having a tree set, you know? So just generally you should try to keep it so that it's consistent. So like descending order, regular order, odds first, evens first, that kind of thing. It should be easily discernible. Even though I obviously can't do that, apparently. But anyways. Alternate comparator. So there's like 3 types of comparators that you could possibly do. So So you can notice that if we use the first type that I just went through, that's like a comparator class, then it's kind of tedious sometimes if you wanted to do like many different types of comparators, that you have to create a class each time for it, and you're probably going to get really sick of that soon. So there's another way you could possibly do the comparator class. And so this is for like if you're not going to use it very much, since if you were going to use that comparator class for multiple different tree sets and tree maps, then it'd be a good idea to put it in a class, since it's easier to do then and you don't have to continuously write it again. But if you weren't going to use it, you might want to do something like this. So in this case, it's a variable more like. So we have comparator integer. So again, that's like the type of it. So we're doing comparator interface integer, and then new comparator integer kind of looks like the same thing. And then we have brackets here. So I'm not going to go over that since it looks basically the same as the other one. So the thing with this one is that it's more of a variable now, an object, if you want to say it like that. So in this case, you don't have, like, it's easier to write. It's all in the main method. You don't have to do anything special with it. And you can notice that, anyways, you can notice that in the bottom here, you can see that, anyways, yeah. So you can see that instead of doing like new random at the bottom, you can see that you can just put the variable here, like the A here goes into here. And that would count as your comparator, and in order as usual. But like, just notice that all of this would go inside the main method. Like, it's easier to write. You could probably agree that it's easier to write, especially if you were just going to use it like 2 times. Okay, explanation and another alternate. So again, this would go in the main method. This would be useful if you don't want to create a class for comparing, if you weren't going to use them very much, that kind of thing. So there's another shortcut kind of way to do it. You could also do something like this if you didn't want to create a variable. So you can see that we have the regular tree set kind of thing. But then instead of like doing like putting a variable name here or putting an object name here, we're doing a new comparator integer, and then notice here that you saw the parentheses here, and then curly brackets. Could continue on the next page, so I'm going to go to the next page. Yeah, so continued, and it looks basically the same as always. It's just a compare method, and then just make sure that when you're doing this, it can be easy to confuse the different parentheses, brackets, and whatnot. So just make sure that you're closing it off correctly. Kind of looks like an emoji, but anyways, so yeah, so you can see here that it saves even more space. You don't have to create like an actual variable for it. You're just able to do it directly inside of the parentheses. And this would again be useful if you just wanted to use it like one time. That's what this would be useful for. So in general, I would say use the class version if you're going to use it like 5 or more times. Then it's good to do it, since if you use this one, you're not going to want to copy and paste the same code over and over again. That's just tedious and not worth it. So in that case, if you find that you're going to have to like copy and paste it like 5 times or more, then it's good to do the class, since it's easier to do. If you were to do it like 2 or 3 times, then maybe it'd be a good idea to do the variable version of it, since it's not too bad, but it's like not too short anyways, and like it's easy to put. And if you're only going to use it like 1 time, then it'd be good to do it like this way, since you can see that decently short with coding compared to the others. Yeah, that's just my spiel for the comparator. So just as a note, if you already used a comparator, then you don't have to use a comparable interface. Since they're both comparing, they do the same thing basically. Since you notice that the compare method is basically the same as compare to method, so there's no difference either way which one you do. Like, but just generally though, if you're doing objects, use comparable. If you're doing if you're doing integers, doubles, that kind of primitive data type kind of stuff, then use comparator. But you don't have to do both. Yeah, I think that is it for this lesson. Sort of important lesson. Like comparing is kind of like, it's good to know, but like at the same time, you don't need to know about it too much unless like you were gonna do a project with that's based a lot on comparing. That just depends on what you're gonna do. So it's important background information regardless. So in a second, we'll be doing class problems. Right, so these are the class problems. We didn't have enough time to do it fully since kind of cut it off a bit late. But anyways, so these are the class problems. Just do them, make sure you understand them. Do the review problem, make sure you understand what we're basing it off of. Also try to do this so that you're familiar with how to do it. Again, we're not going to do as much to determine the output problems as before, since I feel that programming should be like determine output and programming at the same time, since you have to go through and debug it. So I'm not going to create as many determined output problems as before, but programming problems are definite must, and they're going to be increasing. So otherwise, just make sure you understand how to do these, since you might not use it as much, but it's still important to know and increases your understanding of Java. So yeah, otherwise, that'd be it for this lesson.